Hey class, today we are solving systems using tables and graphs, which is found in section 3-1 of your textbook. Our objective is to solve a linear system using a graph or table. Our vocabulary states that when you have two or more related unknowns, you may be able to represent their relationship with a system of equations. A linear system is a system of linear equations. A solution of a system is a set of values such as ordered pairs, for the variable that makes all of the equations true. So in example 1, we are given two equations. Again, remember anything more than one equation or one inequality is considered a system, and we're asked to find the solution, which is where they will intersect. So if we are asked to graph this information, however, even though normally we will not graph because of human error, which is very common, but just as practice, we are going to graph. So in order to graph, we need to be sure that both equations are in slope-intercept form. So let's rewrite these as negative 3x plus 2y equals 8 and x plus 4y equal to negative 12. If we solve each for y, we will add 3x because we're moving x to the other side. We are left with 2y equal to 3x plus 8. Finally, to get y by itself, we will then divide by 2. So y equals 3/2 x plus 4. That is our first equation that we want to graph. All right, moving on to the second equation. Again, we want to get y by itself. We're going to move x by subtracting it. So we're left with 4y equal to negative x minus 12. And finally, we're going to divide each by 4, which will give us y is equal to negative 1/4 x minus 3. So then we're going to graph. Remember, there's always a chance for human error, so we often don't want to rely on this as foolproof, but if ever you're given two equations that are already given in slope-intercept form, that's one quick way to try and get it done, or we'll learn other ways later. Okay, the first one, if I have 3/2 x plus 4, that means I would start at 4 on my y-axis. And I would move up 3, 1, 2, 3 over 2. And we would do that again, up 3 over 2. So it's about here. I'm going to go the opposite direction because when graphing, I try to plot as many points as possible because my goal is to eventually find the one exactly where they intersect in my window. So again, now I'm going to go down 3 and left 2, so that's here. Then down 3, 1, 2, 3 over 2. I'm going to try that one more time just to make sure. I'm going to go down 3, 1, 2, 3, and over 2. So that's going to be about here. And normally when I'm doing this, I save my lines until the end. So I won't create a line until the very end. All right, so the next one, this equation. I'm going to start at negative 3. And I'm going to move down 1 to the right 4. 1, 2, 3, 4. Well, if I keep going in that direction, I will never hit it or intersect that line. So I'm going to go the opposite direction. I'm going to go up 1 to the left 4. 1, 2, 3, 4. And look, there's our intersection. So now I can go ahead and identify that point, which I believe should be 1, 2, 3, 4, negative 4, negative 2. And that will be our solution because that's where our, and I'm not going to hit it correctly, but that's where our pink line intersects and our blue line intersects. And I should put arrows on the ends of those. And that'll be our final answer. We could then go back algebraically and substitute negative 4, negative 2 into each equation. And we will notice that it is a solution because when you substitute the ordered pair back into each equation, you'll notice that both sides of the equation equal one another. So let's practice testing that out just to make sure. So, for example, here, if I have y equals 3/2 x plus 4, y would then be negative 2 equals 3/2, x is negative 4, plus 4. That means that negative 2 equals, that would be negative 12, right? If I multiply, that's negative 12 over 2, which is negative 6, and negative 6 plus 4 is negative 2. So negative 2 equals negative 2, that works. Let's test it over here. Again, y is negative 2, it would equal negative 1/4 times negative 4 minus 3. So negative 2 will equal, again, we're going to multiply, so that's negative 1 times negative 4 is positive 4 over positive 4, which is 1. And 1 minus 3 is negative 2. So negative 2 equals negative 2. So yes, negative 4, negative 2 is a solution to this. And so actually I'll go ahead and add this as another statement. If you are going to use graphing as your way to find the solution, be sure that you go back and check the ordered pair and make sure it works. All right, so let's move on. All right, so in try 1, we have x minus 2y equals 4 and 3x plus y equals 5. So let's go ahead and start that. Remember, our goal is to write each equation in slope-intercept form and then graph. So in the first equation, we're going to move x over by subtracting it. So I have negative 2y equal to negative x plus 4. Then I will divide everything by negative 2. That's a 2. So y will equal 1/2 x minus 2. Second equation, again I want y by itself, so I'm going to subtract 3x on both sides. So y will equal negative 3x plus 5. And now we're going to graph. Again, I'm going to try and put as many points on one line as I can. So let's make this first line our pink line. And so we're going to start at negative 2 and move up 1 to the right 2, up 1 to the right 2, and I'm going to do that one more time, up 1 to the right 2. Now I'm going to go the opposite direction just to make sure I'm correct. Down 1 to the left 2, down 1 to the left 2, and one more time, down 1 to the left 2. Remember, I'm putting so many points because I want to truly find what is my point of intersection. The next line, the blue line, we'll start at 5. So 1, 2, 3, 4, 5. And we're going to go down 3. 1, 2, 3 to the right 1. Do that again. Down 3, 1, 2, 3 to the right 1. And there it is. That's our point. And that point is going to be to negative 1. So let me go ahead now and create my lines. Not as important, but just to go ahead and fix it. And let's make sure that this point works. So here we go. If I substitute in 2, negative 1, I will have, for the first equation, negative 1 equal to 1/2 times 2 minus 2. Remember, if I put that over 1, that means that negative 1 will equal, my numerator will be 2, my denominator will be 2 because 1 times 2 is 2, 2 times 1 is 2. 2 over 2 is 1, so 1 minus 2 is correct, it is negative 1. So that works. I can practice on the blue equation over here, so that'd be negative 1 is equal to negative 3 times 2 plus 5. Negative 1 is equal to negative 6 plus 5, meaning negative 1 equals negative 1. So yes, it works. That is correct. And so 2, negative 1 is the solution to this system. In example 2, we begin using a table to solve the problem. It's almost kind of like our way of doing guess and check, but making it organized by putting it in a table. So in this problem, it says a Greenland shark grows at a rate of 0.75 centimeters per year, and its length at birth is 37 centimeters. A spiny dogfish shark grows at a rate of 1.5 centimeters per year, and its length at birth is 22 centimeters. If the growth rates are constant, at what age would a spiny dogfish and a Greenland shark be the same length? So the first thing that we're actually going to want to do is create an equation based off of this information. So be sure that we can still remember how to write a function rule, but Really, in this case, we're just writing an equation because we're not exactly sure if it's a function or not, even though technically it is. Okay, so for the Greenland shark, the information that matches together is the 0.75 centimeters per year and the length at birth, which is 37 centimeters. So let's say that that equation will be, remember the rate, right? Because we talk about slope as rate of change. The number that is associated with the rate is going to be our slope. And the rate we see is centimeters per year. So that means our equation here is 0.75 x plus 37. So that would be for the Greenland shark. For the spiny dogfish shark, we have a rate of 1.5 centimeters per year and a length at birth of 22 centimeters. So that's going to be y equals 1.5x plus 22. So we're going to use that information to create our table on the next screen. So again, let's remind ourselves of those equations. For the Greenland shark, we'll have y equals, that's equals by the way, 0.75 x plus 37. And the spiny dogfish is y equals 1.5, that's a 1, 1.5x plus 22. So let's, to kind of help us out, we're just going to kind of guess and check. So we know at age 0, it's the length that's given to us. So for the Greenland, it's going to be 37 centimeters, and the spiny dogfish is 22. So we don't really need to start at age 0. So let's start at age, for example, 5. So at 5 years old, if I substitute in this information 0.75 times 5 plus 37. Again, this is our commonly a way that we would guess and check. Sometimes this method takes a very long time, but it is sometimes useful, especially in the case when you're only given the opportunity to graph or to create a table. And in this case, we don't want to create a graph because no one wants to try to count slope with 0.75. I mean, we could change it to a fraction of 3/4, but let's not. So here we go. We have 0.75 times 5, which is 3.75. And if we add that to 37, we get 40.75 centimeters. Okay, so let's do that for the other one. For the spiny dogfish, we'll have 1.5 times 5 plus 22. So in our calculator, 1.5 times 5 is 7.5. And if I add that to 22, I'll get 29.5. And remember, the goal is for them to be the same length. So right now, they're not the same length. So let's bump it up another 5 years. Let's say when they're age 10. So that'll be 0.75 times 10 plus 37. I can go ahead and tell you that's 7.5 plus 37, which will be 44.5. That's a 4, not a y. Sorry. And here I would have 1.5 times 10 plus 22, which is really going to be 15 plus 22, which is 37. Again, they're not the same, but they're catching up to one another. So let's try 15. 15 will be 0.75 times 15 plus 37. So 0.75 times 15 gives us 11.25 plus 37 is 48.25. Let's try that again. 1.5 times 15 plus 22. So 1.5 times 15 is 22.5 plus 22 is 44.5. Very close. Let's try 20. And if 20 doesn't work, if 20 is too far over, then we're going to come back down the scale. So let's try it. 0.75 times 20 plus 37. 0.75 times 20 gives us 15 plus 37 is 52. And 1.5 times 20 plus 37. Well, 1.5 times 20 is 30, and plus 30 Okay, hold on, sorry. 1.5 times 20 is 30, and I'm not supposed to add plus 37. It's supposed to be plus 22. Almost made a mistake. So plus 22 would then be the 52 that we need. So to answer the question, the age at which the two sharks will be the same length is when they are 20 years old. Okay? And so, again, this is our way of finding the solution of two equations using a table. And often I'll call this kind of like a guess and check. So it then says, if the growth rates continue, how long will each shark be when it's 25 years old? And we know that's not difficult at all to find. So again, we have the age, so at 25. And when we were talking about the Greenland shark, that equation was y equals 0.75 x plus 37. So, excuse me, let me get rid of that equals. So I'd have 0.75 times 25 plus 37. So let me get out my calculator. 0.75 times 25 is 18.75 plus 37 will equal 55.75 centimeters. So 25 years old, the Greenland shark is 55.75 centimeters. If I want to find the length for the spiny dogfish, remember that equation was y equals 1.5x plus 22. So that would be 1.5 times 25 plus 22. That would then mean 1.5 times 25 is 37.5. And if I add the 22 to that, its length will be 59.5 centimeters. And so that's the answer to try 2. Moving on, so this is just giving an idea of graphs and what it means for their solutions. So intersecting lines, let's say I have a line that goes this way and I have a line that goes that way. Sorry that they're crooked, but let's just work with it. When lines intersect in this manner, we have only one solution, and that is the one place where the graphs will touch. So here we will have one solution. For coinciding lines, that means that if they're coinciding, that means that my lines actually lie on top of one another. They are the exact same line. And remember, how many points are on a line? Well, there are an infinite amount of points. So that means there are an infinite, or I can say infinitely many solutions. That's an I. Lastly, parallel lines. Parallel lines will actually never intersect, right? So how many solutions can they have? None. So no solution. So there are things that we know about these equations that will then help us to determine without graphing what the solution may be. Okay, so without graphing, we're going to determine if the two equations have 0, 1, or infinitely many solutions. So in order to do that, we want to get both equations to look the exact same. And when proving this on homework or on a quiz, you'll do this exact same thing. So we're going to write both equations in slope-intercept form. So that means we're going to isolate y. In order to isolate y, we need to move everything away from it. So right on the first one, I have a negative 2x that I need to move by adding it to both sides. So I have 4y equal to 2x plus 6. If I divide by 4, I will get that y is equal to 1/2 x plus 3/2. On the next equation, if I divide each term by 8, I will get that y is equal to 1/2 x minus 3/2. What we notice is, yes, the slopes are the same, but the y-intercepts are different. Okay, so for example, if they were 0, if there were no solutions, that means that the lines are parallel. And we know that lines are parallel if they have the same slope. These happen to have the same slope, so let's keep 0 in mind. If it was one solution, that means that not only would my, I may have a slope that is different, and also a y-intercept that is different, or I may share the same y-intercept but different slopes. Either way, it means that they would have different slopes. And here, if they are infinitely meaning solutions, that means the lines will be the exact same. And so what we notice here is that the slopes are the same, the y-intercepts are different. So if we think about that theoretically, that means we would have 0 solutions, because technically our lines are parallel. Okay, so let's practice more. Okay, so on try 3, we have 3 sets of examples technically, so we'll deal with each one separately. So on the first one, I have negative 3x. Oh, I want to switch colors. Sorry. So negative 3x plus y is equal to 4. And I also have x minus 1/3 y equals 1. Again, we want to solve to get y by itself. So on the first one, that means I need to move x over. So I need to add 3x to both sides, which would mean that y is equal to 3x plus 4. The next one, again, I want to move x over, so I'm going to subtract x on both sides. So that lets me have negative 1/3 y is equal to negative x plus 1. And in order to get y by itself here, I would have to get rid of the fraction in front. So to remove the entire fraction, I would have to multiply by that exact fraction, or by its reciprocal, which is going to be 3. But I also need to get rid of the negative. So I'm going to multiply by negative 3 to both sides. If I do that, I will have y is equal to positive 3x minus 3. Again, here we notice that the slopes are the same. If the slopes are the same, that means they are parallel lines. And if we think about parallel lines, they will never intersect. So there are 0 solutions here. All right, let's look at the next one. Okay, on the next equation, we have 2x plus 3y is equal to 1. And we also have 4x plus y equal to negative 3. So again, I want to get y by itself. So if I subtract 2x on both sides, I will have that 3y equals negative 2x plus 1. I would then divide by 3 to isolate y. So y will equal negative 2/3 x plus 1/3. The next one, again, to isolate y, I need to move x over by subtracting it. So y will equal negative 4x minus 3. What we notice here, if it was 0, that means that they are parallel lines, but they don't have the same slope here, so 0 doesn't work. If they were infinitely meaning solutions, the equations would look the exact same. So that must mean that our answer is 1. There is one solution. We don't need to know what that one solution is currently, but if we did, we would then go on to graph both of them and find their intersection. Okay, and the last example, we don't need to change the first one because it's already in slope-intercept form, so let's just change the last one. So I'll move x over by subtracting 6x, doing the opposite. And I would have negative 3y is equal to negative 6x plus 9. So if I divide by -3 to every term, I will have that y equals 2x minus 3. And look at that, they are the exact same, so that is infinitely many solutions. Because they are the exact same line. Again, guys, here's your homework. Pre-AP, you have the first assignment. Regular Algebra 2, you have the second assignment. If you have any questions, see me for tutoring. Bye, guys.